Okay, hello everyone, my name is Zhuang Tijie, and today I'm talking about what's used as laser in the future. And a laser acronym derives from light amplification by stimulate emission of radiation. Typically involves power source, gain medium, and resonator. Progress in laser technology depends on advancing one or more of these elements, and the general measure with respect to some technical characteristic of the beam, such as energy or pulse length. So the highest energy lasers today are found at Lawrence Livermore National Laboratory, and these deliver beam energies as high as 2.2 megajoules and have been used to drive control nuclear fusion reactors at the lab and produce a net energy gain. As for pulse length, the generation of attosecond pulse was recognized with the Nobel Prize in Physics in 2023, and these pulses are shorter than the timescales of electronic motion within atoms, so it enables atomic process to be observed. So the basic operation principle and physics of lasers are generally well understood, and the following are some examples of important applications. So, quantum computing. Lasers can cool matters to extremely low temperatures, near absolute zero. So this ultra-cold environment allows atoms to exhibit quantum behaviors. Such laser-cooled or laser-trapped atoms are used to create and control qubits, makes them an important platform for quantum computing research. Chip fabrication. High-power lasers are essential for modern chip fabrications, especially for creating features smaller than 100 nanometers. So extreme ultraviolet lithography use laser to evaporate thin droplets and generate UV light for projecting circuit patterns onto silicon wafers. So in this process, through inefficient, but it's crucial for producing cutting-edge chips with features below 2 nanometers, which are vital for high performance, energy efficiency, and miniaturized application. Communications. Lasers are also essential for modern communications. Transmitting data through fiber optic cable can enable high-speed satellite-to-satellite links, and laser communications offer much faster data rates, greater security, and higher energy efficiency compared to traditional radio system. While beam alignment and atmospheric interference are technical challenges, lasers are already used in space-based systems like Starlink and NASA's experimental links, and efforts continue to expand their use for ground-to-space and air-to-space communications. Nuclear fusion. Nuclear fusions release energy from when light atomic nuclei combines to form heavier nuclei. So the main challenge for using fusion are an energy source is confining the field long enough to ignition. So one of the approaches is inertial confinement, which employs high energy lasers to rapidly compress fuel pellet. And developing commercial viable inertial fusion require powerful, efficient lasers capable of precise, symmetric compressions. So enable better measurement and modeling of future fusion processes. So overall, lasers could fairly be regarded as an enable technology, that is, technology whose existence may and characteristics enable applications that would be not otherwise be feasible or affordable in the future. Thank you.
Do you know where most of the lasers are used for?
Laser is, I think it's a lot of use.
Like where are most lasers? So like how big are the most common lasers? So it used to be that they are CD and DVD players, so that nobody's using them anymore. So now it's laser printers. So, but I'm curious, what do you think will? So there's a lot of companies that make lasers, and they're getting cheaper and cheaper. What do you think they're going to be selling? What's going to be like? Because nuclear fusion, for example, is going to be useful for maybe like a couple of very big facilities. But where are you going to sell lasers to?
Maybe in car systems.
Like what do you? Oh, like back in the 2000s, people were thinking that they would use lasers for the car lights. Instead of having like LEDs on the car, they were thinking of using lasers for that. I don't know what happened to them. But I think they kind of figured out that physics is not that easy because you're getting something called speckle. Like it's hard to see with a laser. So, what do you mean by car?
I think the Internet of Things are popular right now, so maybe they use laser to connect with everything on the road.
Like there's lights on it, right? People want to use like light to beam information. That's one. But I think you're right. Like for cars, for detection, people use water, which is light emission to see how far something is away. So that's in self-driving cars. We were in California and we were driving the Waymo, and it has a big laser turret on the top that just keeps spinning and checking where everything is. So I think cars will need thousands or hundreds of those laser ranging devices on everything to know where they are. So I think there's still a lot of light electric, but also just shooting down drones.
Like military.
Well, I mean, the military has our lasers, but they're normally gas-based.
Oh.
Basically, you take a gas cartridge and then you throw it away after 10 shots. So if you could do that with a solid-state laser, it might get much cheaper. Just other questions?